Okay, well, I guess we'll kick things off. GM, my name is Boris. I'm from the ecosystem team at Aligned. Today, Diego, who is one of our co-founders and our head of research, we are being joined by a couple of guests. One is coming shortly, but for now we have Karel, who is the founder of Union. Welcome, guys. Super excited to talk about ZK and interoperability today, and I'm sure there's going to be a lot of interesting stuff we can share with people listening in. So how's it going? Welcome. Thank you for coming.
Yeah, thanks so much for having me. Happy to be here. I think this is the first stream I'm doing with you guys, right?
Yes.
Yeah, I guess so.
Yeah, so I remember hosting you back in the summer on a space along with Andrew from Versatis, and they've rebranded to Formation now, I think. And that was a really great conversation. So I can tell the little story about why I've been digging into interoperability a bit more recently. But I thought it would be great to have you on again. And as of last week, we started doing these streams on Friday, and we're going to try to do a lot more of these. Figured it's a little more fun in some ways for people to be able to see actual faces and leave comments pretty easily. So we're experimenting with this, and for anyone listening, we'd love to hear what you think, or if you have ideas or recommendations as well, guests you'd like to see us bring on. So, we'd love your feedback. But yeah, so I guess we can just jump right in. I mean, I prepared some of those kind of guiding questions to give you all an idea of some of the topics that I at least personally think are interesting related to ZK and interoperability. But really, I just wanted to hear your thoughts and opinions and your perspective on how we can solve interop. And maybe even a good way to start is like, well, what is the interoperability problem that we see today within crypto?
Yeah, so I think everyone is kind of familiar with bridging being a pain. But I think when we discuss like the interoperability problem that we see right now, with that we also anticipate the increase in chains, L2s, L3s, whatever you want to call it, but separate state machines, right? And with like this whole modular thesis, Celestia, now kind of the movement ecosystem of L2s, this only keeps expanding. This harkens a bit back to Cosmos's original app chain thesis, which is that if you want like really good UX for your end users, you kind of want a dedicated chain so that if another application like suddenly spikes in popularity, your users are not affected by this. What we see happen then initially when you have bad interop is that every new chain needs to create its whole ecosystem. Instead of a DEX lending market, like everything needs to be basically bootstrapped. They see these kind of copycat protocols almost because, right, like you need a DEX to do liquidations for lending markets. So if you want a chain specifically for loans, then you kind of need a way to still trade assets. And so for me, the interoperability problem really here is that interop right now is not good enough for different chains and L2s to rely on each other. Right, I cannot really create a hyperliquid, but then like as a lending market, and then rely on hyperliquid itself to do the liquidations at the moment. Like the latency is too big for that. So I can send like a message and then wait 5 minutes, right, with a bunch of assets to do a trade. But then what will happen is people will observe this and they're going to trade on this idea. So if I do a really big liquidation, obviously the market price will be altered 5 minutes later. I need to have different parameters if I do this related to how much collateral you need, because the longer it takes to liquidate, right, the 5 minute latency window, the more collateral a user needs to put in to hedge against that price difference risk. So right now, if you were to like create a chain and rely on a few other chains for these services, then you just wouldn't have a good app, to be honest. And so what do we need to fix for this is like really fast interop. That's one big thing that we need to solve. More in the mind of something that's used at like a systems level, right? Like a backend service for smart contracts itself, not necessarily for users. So for that, you need better reliability as well. You can't really like ask a smart contract to hop into Discord and ask the bridge protocol, like, help, my transfer is stuck. Right, like it needs to kind of level up in quality.
Agentic bridges one day.
Exactly. Yeah. You
Hey,
can't do that.
can you bridge this for me?
Yeah. And then finally, the great power right now of like a general purpose chain in L1 is I can deploy a smart contract and connect with whatever other DeFi protocol I want without needing to talk with any team, right? Like I can leverage Uniswap without talking to the Uniswap team. I can like deploy a pool and like integrate in my protocol. I can use Morpho, etc. Right now in this kind of like Interop bridge world itself, if I build a chain, like I can't just open connections to 3 other chains and rely on them. I kind of need to ping the team, and we need to discuss like which bridge provider are we using. Oh yeah, well, like this one is good, so it's $1 million per year, and it's going to take like 9 months to support you. So I think the third thing to solve it is like you have to basically, from a smart contract, automatically be able to open a bridge connection permissionlessly. Right, the same way you kind of like instantiate a new contract, you need to be able to open a connection as well and start like receiving and sending assets. And that final thing actually has like a lot of nuance to it, because if you're going to allow like these things to be opened automatically without like different teams knowing each other, now you're working in a world where it's adversarial, right? There's no contract, there's no agreement that the chain is going to behave nicely. So I might deploy a blockchain myself, which like the blockchain code itself is malicious. Like the EVM I've deployed just doesn't behave like an EVM should. So you need to think about security a lot more now. You can't like really rely on like some shared multisig, for example, because once again, adversarial environment. And so this is why I'm so excited about ZK, because here's where kind of the ZK component comes in, where now you have this kind of way where you start talking about proofs, and it doesn't matter who generates the proof, right? Where it comes from. You don't need a dedicated team to that. You don't need a specific address that's submitting the proofs. Like anyone can do this. And so kind of that's the first part why I think ZK Interop is really interesting. It allows us to once again start doing Interop in a highly adversarial environment, and like do this in that like kind of original permissions way. And that's at least the objective for me with Union is, can we at some point get Interop to be as good as if we're all on the same general purpose album, right? Like that's kind of the North Star. Like, can we get 10,000 blockchains to kind of behave the same way together, provide the same developer experience as if we're all on one massive chain together?
Interesting. Okay, so I feel like I've thought about a lot of these different dimensions to what would make for a good bridging or interoperability experience. I guess bridging is like one case of interoperability, but probably the one that most people think about. And oh, I think we have Greg here, so I'll add him in a second. Yes, I'm going to add him to the stage. Hello, Greg.
Hey, nice to see you all.
Welcome. Thanks for joining us. We just got started with Karel, sort of giving his views on the interoperability problem right now, and sort of hinting at some of the later parts of the things we want to get into, like how ZK can address some of these issues. And I was just trying to summarize. So I mean, we need low latency, because obviously if you need to do anything cross-chain that is time sensitive, say in DeFi, this is super important, or people get liquidated and UX is bad. Has to be secure, and this can be an issue if we have any arbitrary chain that it itself could be malicious, getting involved in bridging with other chains. And what was and I guess actually integrations and making sure that it's actually easy to connect different contracts and chains, right?
Yeah, I started chilling ZK because I think if in a world where like a regular developer might want to deploy their own chain for their own specific app, we don't want a world where they need to like ping teams and say, I want to open a connection to you. You want that to kind of be completely autonomous and automatic. And then you have to ditch the multi-sig, obviously, because there's no like kind of shared Oracle or multi-sig that we want to use. And instead leverage a world where it's only communication by proofs, ideally.
Yeah. So, Greg, how about you? Is there anything else you would like to add on the topic of Interop? I also want to give both of you a chance to just talk about, what you're working on and how it relates to the topic, of course. But the primer.
Yeah, Interop's a big question. Interop something I've been and we've been working on at Chainsafe for a very long time, like probably 2018 era. And it looks like it's getting better. And there's a lot of standards groups like trying to fix that right now, which is nice. I think ultimately, I think the thing that matters is that we have a form of verification at transport level that is secure enough. And it's not about getting down to like, millisecond confirmation times between them. It's like, 1-2 seconds, that's adequate enough, 1-2 flags. It'd be nice to see that this year. I'm hopeful.
Yeah, I think just upgrading from a world where it's a 2-minute confirmation time to kind of like a 2-second one is already a big one. I do think there exists an end state where basically loads of chains are, 500 millisecond block time, single slot finality, ultra machines, and where we can generate a ZKP in like 50 milliseconds. And that basically, like, what to the user seems almost instantaneous, right? This might be, I don't know, 5, 10, 20 years away. But that's at least the end state that I'm hoping for. And that we can kind of achieve like full end-to-end finalized like bridge operations within like a second.
I saw a tweet yesterday that was saying, or talking about how, Interop being solved has been 6 months away for like 5 years. And there was a bit of timely conversation around that. And I mean, I'm relatively new to the space, so this is only something I've started really thinking more deeply about recently. But clearly, you guys have been thinking about this for a very long time. On that latency thing, I mean, I think I saw something about how for most users, like instantaneous is actually like 150 milliseconds. Like for somebody using an app, there's a number where it's like it actually doesn't need to be faster than that because people don't need to see things change on their screen faster than that for them to think it's instant.
Yeah, and I think there's kind of like 2 layers to this. You can have the one where like the settlement is fully complete. But if you use like a solver, for example, that would be like, when does the solver have inventory again that they can reuse? And then there's a UX portion, like what is a user experience, which is like, when does the check mark turn green and does their wallet display that they now have 100 USDC on another chain? And I think there's some really cool tricks that you can do to speed the user portion up. So on the union side, for example, we have 2 bridging methods, like any order can be filled by anyone, or you can do the ZKP and then the assets are minted or released from a pool. Technically, let's say you're a wallet or an MPC-based wallet or a safe, for example, and you know that a user cannot double spend, then a solver is technically free to already provide a user their assets on the destination side before the transaction is even included on the source side, as long as you know it's going to be included on the source side, which, let's say, an exchange or a Revolut or something that has a much more managed wallet environment where a user doesn't actually control the private key themselves, you can guarantee this. And so you can kind of leverage this little trick to already provide the user their 100 USDC basically immediately, and ensure the settlement portion might still take between 20 seconds and a minute, but you can provide that UX that does seem completely instantaneous.
Yeah. I mean, as somebody who has dabbled in DeFi and done, I think, a fair share of stuff on chain over the past couple of years, this is actually interesting. Like, even on Ethereum, the whole finality aspect of user experience has never, I mean, it's always felt relatively quick. Sure, you might wait a couple minutes for a bridge and they have a little thing and you're sitting there. I remember bridging to Polygon and I was so scared. This is my first time doing something on chain. I'm like, it's going to take 30 minutes. I'm like, did I do something wrong? I'm like reading forums and Googling stuff. But most of the time, if I'm just staying within, a single, I don't know, single chain, it is actually like quick enough. Like I expect it to be slow, but if I'm doing like a swap on Uniswap on like mainnet, like it has kind of felt fast enough in a lot of ways. But I don't know. I don't know if other people agree.
I think we've geared our UIs on the Ethereum side a lot to deal with this, right? Like our regular swap interface, like almost hides away and doesn't allow you to do another swap for about 10 seconds, right? Showing you the details. And that's, for example, why we don't have as many UIs that like resemble like true exchanges with candles, allowing you to open like many orders all the time, closing them quickly. So I think we've right now kind of worked our way around it by just making the UX anticipate like a 15-second feedback cycle.
Interesting. So the UX works to cover up the problems.
Yeah. I think for all use cases, like faster is just always better. Like, there's never downside to being able to handle a user request in half the time.
Yeah. Not trying to be a latency apologist or anything. I was just, the idea kind of came by. I'm like, I've never really thought about how that was an issue, but maybe there's a good reason for that. Yeah. So Greg, I want to hear both of you explain the respective approaches you're taking to Interop and the maybe specific aspects of Interop that you might be focused on right now or in the future. We can talk about ZK whenever it's relevant, obviously, but I'd love to hear. I know there have been some exciting announcements, an acquisition of a solver. What's that all about? Tell us about Spectre.
Yeah, definitely. So yeah, maybe some background context. I mean, so we started building bridges around the time when Gurley went live. So we launched Gurley at the test at East Berlin, and then needed an incentivized mechanism. So we built this like multi-directional bridge, which was an upgrade of what Parity had been building back in the day. And basically the idea was like the Parity bridge could only go like one to one. And so we were like, okay, let's just like burn a bunch of Coven and Ropsten ETH and Rink ETH, and you get like a 5x multiplier on the Gurley side. And it was like our way to try and like give devs like some bootstrapping. That eventually led us to just build out this like open source framework that a lot of people used. Any swap multi-chain used it for a bit, and there was a bunch of things like multi-collateral DAI was being bridged in and stuff like that. Long story short, we're kind of pivoted more into like a solving team. So we took like 6-7 years of cross-chain interop experience, and started merging that with the Project Blanc team, to basically like, because they're in the top 3 CASWAP side of things, on the AMM side of things, and so kind of merging those efforts together to effectively just build like a more robust solver platform. We've got some announcements coming up like on the liquidity side of things in Denver, but like we're really focused on basically like I think filling those. I think just like improving the quality of life of like orders being filled cross chain, because like that was mentioned earlier, fill times can be like super all over the place. The main reason for it is due to order size, volume, and fees just like not being where a lot of people want, and inventory becomes a big problem. So we're hoping we have a really good solution to that, and looking to kind of solve that. Outside of that, Interop stuff, ZK. I mean, we developed. I think it was the first like client, Ethereum like client ZK implementation out there. It's live on Hashi right now, although it's like not really a huge focus for us anymore. Called Spectre.
Spectre,
yeah. Yeah, we built it back in Bogota, just kind of like as a fun little hack, and then it turned out people kind of needed it, and then light client protocol is kind of not where it should be, so not so secure.
Very cool, Greg. Yeah, actually, this is maybe a good time for me to mention Spectre and why I recently started digging into this topic a little bit more, and it's because someone from your team actually did a very cool hackathon project for the hackathon we did back in October, where he took this Spectre light client, which so Hashi is like the Gnosis bridge, I think, right? Yeah. And basically to make it compatible with Align for verification, to just make the verification costs cheaper for anyone using that ZK light client for Ethereum. Because I think it was built with Halo 2 circuits, and those weren't immediately possible to verify on a line, he actually re-implemented those circuits inside RISC-0. So that way it could, basically run the light client inside RISC-0, CKVM, and then verify the proofs of the line. So that kind of led me down this rabbit hole of researching how ZK is involved in Interop and seeing who I could invite for a conversation on the topic. But you guys are shifting focus from that to this sort of liquidity-based Interop model. Interesting. Okay.
Yeah.
Karel, so on the union side, I have looked into your stuff before, but I am curious to hear about what's new. And I remember at the time doing a bit of research and seeing that there were, you're going to potentially use Line to verify consensus proofs within your chain that's providing all the interop, right? But curious just to hear about the general approach as well. I think a lot of people would be excited to hear that.
Yeah, so on the union side, at the base, we basically took the IBC protocol, which originates from the Cosmos, and we made some alterations to it. We, I would say, made it a bit leaner, which actually right now is being backported to IBC v2. So some of the changes we made have gotten in there. We have some other protocol changes that make it even more efficient on the gas side, because we altered the protocol to be usable on the Ethereum L1, which obviously means you're gas solving a lot. You're having a good look at what's actually happening under the hood. One of those things we had to do was indeed no longer do live client verification just in Solidity, but do ZKPs for this, because otherwise your unit economics just fall apart. Every single transfer and general message that you're sending just becomes way too expensive to verify. And with Aligned, that becomes even cheaper. So we published a research article on this, on where the gas costs go towards. And with Aligned, we are slightly more expensive than across, but I think it's 15K gas per transfer on the destination side more expensive. So it actually gets really, really good. And this is if you do about 10 transfers per batch. Now, advantages of Union's model with the ZK portion is obviously you batch across multiple chains. So it's not like if there's 10 transfers from bearer chain to Ethereum, you get a benefit. But there's also a benefit if there is 2 transfers from movement, one from bearer chain, one from Stride. You still have the aggregated cost for this. So that is kind of where ZK really starts to shine compared to, for example, Xstar's multisig model. There you don't get this scaling behavior at the moment. So that's at least what really excited me. And when we did the gas cost article, once we finished the gas optimization, it was really cool to see that it actually worked out to scale very nicely, because we initially anticipated that Union would be relatively more expensive but more secure. That would be kind of our market segment. But it kind of turns out that you can be very competitive with other bridges. At the core, I think everyone here is familiar with kind of the idea of using ZK for bridging, but you have a consensus proof. That way you get a header on another chain, and from that moment on, you can do storage proof for whatever else you want to do in the protocol. We then abide by what IBC does. So we have kind of a model that looks like packets being sent back and forth. So we implemented general message passing first, and on top of that, we did asset transfers. And then our, I think, biggest addition that really excites me is, so apps can opt in and say this packet has certain semantics that allow me to accept it from any party without verification. One such semantic can be an asset transfer, because you transfer the assets from the message.sender. So if it's an incorrect packet, then the person who did the transaction loses money, so the hacker would lose money. So you know that this is actually secure to do. What this at scale allows you to do is solvers can kind of look at all Union order flow and see which one they find valuable or not, and selectively choose to settle them themselves. And so you get kind of an automatic fast path, where if a user sets a transfer fee high enough, or I don't know, there's maybe someone wanting to bridge the other way, a solver can basically fast track this transfer, provide the assets themselves, and get the original assets on the source chain back from Union, without being a secondary protocol that lives on top of Union. So it's not like we have 2 different lanes and 2 different APIs for developers. It's actually the same API. And so as long as developers for certain endpoints opt in and say this endpoint opts into this version, they'll just automatically see this happen. And as a solver, you can basically just inspect everyone that hooks in on Union. And you might see certain apps where transfers are taking 2 minutes and look at the packets and go, hey, I can actually just settle these myself in 2 seconds and take all of these fees myself as well. And so then you get this really cool mechanism where the protocol kind of auto optimizes to do faster transfers, which is good for UX. And that was not something that was present in IBC yet. And that's not something you really see, I think, in other trustless bridging protocols. A lot of teams focus a lot on the core cryptography portion and have this like very nice formal model. And we kind of have this hybrid model, which I think will yield in really good UX for the end user overall.
That's super cool. I have a couple questions. So you kind of answered the first one, which is the incentive for solvers to participate here and to more quickly settle these transfers, right? I guess they're getting the full fees from whatever the user is paying to do that.
Yeah.
Now,
correct.
my question then is, so what about in situations where there is no solver who can take care of that, who can settle all of that instantly? Like, where do the incentives come for that to actually get, finalized or settled quickly? Does Union provide that somehow? Like,
yeah, so we have the mode where we can mint assets. So that always works, obviously. But then you get a Union wrapped asset version. But there you always have liquidity for that. The other modes, like a solver, can provide the assets that are necessary. For both pathways, we have a timeout mechanism as well. So whenever you submit a transfer on chain, you can say this has to be like delivered before the counterparty reaches a certain height. And so if no solver has liquidity available, we basically leverage the same timeout mechanism to refund the funds for the user. So as a user, you're actually always guaranteed to either get your funds on the other side or be able to claim them back. And the timeout mechanism that also hooks into our client misbehavior mechanism. So for example, if another chain, double finalizes, equivocates, or if it doesn't produce blocks for a certain amount of blocks or periods, then also you can basically provide that on the source chain and say, hey, this counterparty like disappeared, might no longer exist, might be bricked, etc. Triggers the same timeout mechanism to grant you refunds. So even while the funds are in flight, basically like Union has not taken custody of these funds. And if you just set your timeout to 5 minutes, no liquidity or a chain that has gone offline, either way, you're going to get your funds back. Now, the solver API that we've built, like it basically does not care where the tokens come from. So if someone wants to, they can actually like build in a liquidity pool model as well, where the solver can basically like show the Union proof, the ZKP, to the liquidity pool and say, I'm going to withdraw it from here. I'm going to get it back on the pool on the other side. So that's something that we might build or someone else could build quite easily. I'm still a bigger fan, to be honest, of solvers over doing a liquidity pool-based model, because solvers are just better at moving funds around according to where traffic is currently going. Liquidity pool model, where it's managed by smart contracts, you always struggle a little bit more on where to allocate funds.
Interesting. So I guess anytime we're talking about solvers, we are talking about intents as well, right? Like there's sort of like an intent that you set as a user that this bridging action, cross-chain action needs to happen within a certain amount of time or it gets canceled.
Yeah, I try to like not use the word intents because I feel like it's so overloaded. I try to get people to use open filling, but that never caught on. But I feel like that's really what Union does. Like it allows the order to be filled by various different parties. Like doesn't care who it's being filled by. And then that I think better describes what actually happens. But right now, yeah, in the market, people call this intent-based bridging. But now with Anoma, obviously intents become a lot more complex as well. And I think more towards what I originally thought they were, which is more an abstract description of what you want to achieve.
Very cool. Yeah, Diego, I don't know if you were part of the group that wrote that blog post we put out a few weeks ago on a design for intent-based ZK bridges.
Yeah, no, it was more a work by RJ and Fede. RJ originally was working on this kind of bridge, and we came across this problem that you have to verify proofs in order to update a state, and that is like super expensive. in Ethereum, and the reason is generally generating zero knowledge proofs is computationally intensive. Okay, and it depends on the kind of primitives you use. So, for example, one primitive that you have to use a lot is hashing. Okay, and proving, for example, Keccak hashing is more expensive than doing Poseidon hashing. Okay, so it was logical that some projects would like say, okay, I prefer to use another kind of hash function because that way I can prove it like much faster, and maybe you have like then or we are closer to having like real-time proof generation. The problem is those primitives are not fully supported in Ethereum. You don't have like precompiles including the EVM, so executing them normally takes a lot of gas. Okay, so one of the things we were working, I was at that time in Lambda, was the Mina bridge. Okay, Mina has this very cool idea where you have a succinct blockchain, which is something I think that uh, many will try to transition to, because you have a succinct state and then you have this interesting proof that you know that the genesis was correct, and then you have this inductive proof that you have that if step n is correctly done, step n+1 was derived correctly, and you can go all the step until genesis, and that way you don't have to get all the history of the chain. You just need the latest proof. Okay, but to do that and generate it in a reasonable amount of time, they were using Poseidon hashing. And then if you want to verify that on Ethereum, you have to verify the expensive kinship proof. It's expensive because of how the EVM works, not because it's computationally intensive. It requires like a lot of CPU power to verify the proof. Okay, and then you have to also check the consensus. So it was like super complicated. That's why we said like, okay, can't we get somehow rid of the EVM? And that's why we built Aligned. So what we saw was, okay, we found this problem that we have if we want to build our bridge. This is a problem other L2s are facing, okay, or other CK projects, because every time you want to verify, I don't know, even a gross-16 proof, you have to spend 250K gas. So it was like, this limits a lot the kind of things you want to do. So it was like, okay, let's build Aligned, solve this, because we have eigenlayer. We don't have to bootstrap the economic security of the network, and we can do things much faster. So we saw the problem and said, okay, some people will be able to use all this technology. And so we are happy to have, for example, Union as partner, because it shows that Aligned is solving a problem that projects face when they want to use CK. Okay, we know CK is the answer to many problems, but if to use it, you have to spend a lot of money, then it's not practical. So that's why we got there. And that explains maybe why CK bridging was not that easy, because you have like good primitives that are good for CK, but they are not cheap in Ethereum.
I'm really curious about cost wise. Maybe if either of you guys can comment on this, like the actual proving costs and the latency associated with that in systems you've built or are working on. Like, is this a bottleneck that is impacting UX, or do you have any, I don't know, anecdotes, thoughts on that?
So from what we've seen so far with like proving for our testnets, is the actual proving costs is like the easy portion. And initially we like our first system was connected to Sepolia, and actually even Sepolia ETH is like quite expensive and hard to come by. So there as well, we actually ran into more gas issues than actual proving cost issues. I think like access to good hardware is still quite easy, and hardware even in the last 3 years like improved very significantly. And now with Ingoyama and their Icicle I think V2 library, like we still see like a lot of improvements on the GPU side for proving. I think we're actually very early still in like the optimization path for the whole ZK stack. So far that's been like not an issue. Also, This is like more of a from the business side, but there's quite a lot of very well-funded companies right now who do proving as a service or proving networks. And because they're so well-funded and they're trying to get a large market share, they offer proving services extremely cheap at the moment, if not free, to be honest. So we wanted to like allow people to run a solver at home on their laptop or on like hardware that like a regular like hobby developer has access to, something that only costs a couple $100 per month. And so far that is very doable. Like you can run a stack on that. You don't need like a 500K investment or partnership with a data center to do proving. It depends on the use case, of course, like what you're doing.
Interesting. How about you, Greg? Is this something that you've noticed cost-wise when running like earlier iterations of your protocol?
Yeah, I don't think there's any like hidden secret. This stuff's not cheap.
Yeah.
And we were running like raw, straight on the EVM. So wasn't great. Testnet is like really good prover networks now. Yeah, I mean things on the EVM just cost a lot to begin with, irrespective. So funky math.
Yeah. No, definitely, and that's what we're totally focused on as well. Just trying to make at least verification much cheaper. So send some proofs, guys, and we'll save some money when you need to verify them on Ethereum. Yeah. So, I mean, again, you guys have both or all been paying attention to interoperability for much longer than me, and I am always interested in I don't know, trying to get you to predict what interop might look like in a year or 3 years from now, and maybe I don't know, your thoughts on what is actually needed, I don't know, either technologically or even socially, from like a market structure perspective, to achieve this, to actually like have safe, fast, secure, good UX, good developer experience bridging, or other types of interoperability, general message passing, whatever you think is relevant. Big open-ended question. But...
Yeah, so like I think I kind of alluded on this first, like what's necessary to make interoperability like good. But we encountered, like actually analyzing our competitors' products, like a lot of issues that you still encounter as a developer, and some are like seem very solvable, turn out to be quite difficult to do. But good APIs to inspect where the transfer is at the moment, right? And what's getting stuck, what's happening, those miss a lot. And depending on the bridge protocol that you use, it's kind of like a black hole. You interact with the smart contract, you get an event for that, and you know that at some point you have the funds. But if it goes missing in between, then there's no way to figure out what's going on. So there's like that's kind of part of like the complexity of developer tools that's currently lacking, especially spawning different VMs, right? There's like great tooling for the EVM, but there's not really great tooling if you're combining SVM, EVM, MoveVM, Cosmos chains and trying to figure out what's going on with that. So that's one thing that we had to build a lot in Union to simply work across these chains and these protocols. So nothing proving related, but that's one thing we encountered. I think for in general, like making more applications benefit from ZK and like lowering gas cost. I do think you kind of see the same trend, which is right now, if you develop like on an L1, you basically deploy a smart contract and a stateless UI and you're done, which is like really a blessing, right? Like from an engineering perspective, you don't need to maintain any infrastructure. Sometimes you might need indexing if you do historical stuff, and then you kind of already hate your life, but then you have the graph and you can get around this. Now, if you choose to like offload some of your core logic and do a ZK portion, now all of a sudden you are once again like deploying more infra outside of the L1, like things you have to maintain. Sure, you might interact with the prover network, but you're probably going to need infrastructure to monitor prover network uptime. and if like they're actually being submitted, right, and which ones have been missed or what the latency is, etc. So if you actually like broaden out your stack like that at the moment, you do make your stack significantly more complex than it used to be. So I think that's like when we played around with prover networks, was still something that we were missing a little bit. And actually, like for you, Diego, like so some advice for lines, like it made our relayer, for example, more complex, because our relayer in its base mode, it like provides a proof plus the bridge messages and like one single batch transfer on Ethereum, and you're done, right? The transaction succeeds. You don't need to monitor anything. But through the aligned pathway, you obviously have to interact with aligned and then kind of see when aligned has actually like submitted the proof before you can submit the second half, which it's not rocket science to do this, right? And we worked around it, and I don't think there's really a solution to it, but it just shows like it becomes slightly more complex with what developers have to manage. And I think every incremental increase in complexity, like you lose a lot of devs, obviously. Right? That's why Stripe is so successful. Like copy this one code snippet and you're absolutely done. There's no need for 4 tabs and 2 different deployments to get your stuff to work.
Yeah, no, totally. Yeah, we were discussing with Mauro how to improve like several things that we know that can be improved in Aligned. And it's always good to know what our partners need from our side. So yeah, I think this will be something we will be working on. We already have like some ideas also to reduce costs and even like simplify a lot the design of Aligned. But I think should be sharing a roadmap really soon. We've been discussing, and I don't know if you saw, but there has been a little bit of rebranding also. So it's good to add new things to do.
Yes, yeah. Today we're launching our new branding, and I don't know if you guys can all see the logo that I have, the icon on this streaming window, or if it's just me who's controlling it that can see it. But yeah, we finally have our new website ready, so we're like rolling that out today. But didn't want to talk about that on this stream. Wanted to keep things as focused as possible. Yeah, I actually saw something yesterday, which is kind of relevant, because you mentioned the tooling deficiencies with, say, like alternative VMs. And there was this big news yesterday that Catalyst got acquired by LiFi, and they I think they were focusing on like alt VM bridging, interop, liquidity, provisioning, and stuff. Curious to hear what you guys think about that.
Yeah, I'm happy for Jim. I originally invested in Catalyst as well. I think they originally did the DEX, so technically all the way back they were actually competing, not with LiFi, but with Jumper. They were competing, but then they focused a bit more on alt VM market, and their model with Crosscats is more based on kind of atomic swap-ish. So they do like a proof, for example, for if you do a Bitcoin to a VM, but they only like can do from the Bitcoin network to an alt VM. They can't really do the other way back, because you can't verify anything on Bitcoin. Like you can't do anything complex on top. So for that, they rely on a solver, basically, for that other half. And so it was quite like a complex model with like a few back and forth interactions. So I think it fits really nicely in LiFi's product suite, because right, it's not just a simple smart contract based protocol, and it's not like uniform everywhere. So it kind of requires like more complex integrations with different markets on the back end. So that I quite like. So curious to see where this ends up. We're looking to integrate with LiFi as well. So I think in the end, they're going to be maybe the big winners and have every single bridge protocol under the hood under one interface.
Cool. Yeah, there's also this other thing, and just other exciting topics that I think we've probably all been following around, like base rollups and native rollups. And this just got me thinking that, at least within the Ethereum and like L2 ecosystem, like interop might be solved by this sort of, sooner than later, if we have like synchronous or asynchronous composability even. with like strong guarantees between L2s, right? That kind of like bakes in all of the interoperability most people would probably need. Or maybe I'm wrong. I don't know. Like, I haven't thought about this much. It just popped into my head.
Yeah, based rollups, to be honest, like really remind me of Polkadot parachains, and that's the ecosystem I worked in a couple of years ago. And Ethereum's like L2-centric roadmap just becomes closer and closer to Polkadot tech, and the base rollups are almost kind of a one-on-one expression of that again, which Polkadot too early, but like I really like the model. Like it does work and it does make the most sense, to be honest. But then once again, like then you only have ETH L2s all in the one standard. So it's once again one more standard competing with 15 others. I'm not sure how it's going to play out. To me, it's more like the game theory aspect, but does an L2 team want to be based, right? Or do you give out like your sequencer fees? Do you lose out on maybe like extra experimentation that you can do in the L2? Maybe you have, I would say, like almost out of consensus product features. You see, for example, Skip Protocol, they had an Oracle that they integrated with the validator nodes themselves. So you get like Oracle updates like every single block really rapidly. And you can't really do this like inside an EVM. Like it's kind of a cheat code, but you build it directly in the nodes. So I'm wondering like based rollups can still do that, because I think the execute opcode that they're now talking about, right, needs to evaluate the whole VM. So you might not be able to do these types of features. And so what makes a based rollup then stand out, right? How do you gain market share and have a better experience for your users without being able to use those features?
Interesting. A lot to think about. Yeah. That was one of the early things that I wondered about when I was first getting exposed to base rollups. I think this was back in like June when I don't know, I feel like it started popping up everywhere as a term. And it was, this really simple question. It's like, okay, if they're based, then are they losing sequencer fees? And then how is the rollup making money?
Yeah, I like we already want synchronous composability, right? Because it allows flash loans basically. Like that's the one thing you can do with asynchronous composability, right? Like perform a flash loan. But I feel like in practice it's going to be quite expensive, because you basically need to coordinate sequencing for like two state machines, right? Which probably effectively means like don't process transactions, execute the first portion on one, then execute the second portion on the other, and then the third and final portion on the first one again. So it's kind of like two databases having to coordinate one single transaction, which is always expensive. That's just fundamental computer science doing that, which means that like the associated cost with synchronous composability is much higher than if you do it asynchronously. So I'm still kind of thinking like, well, probably like the world where we just have really fast blockchains and we can like do bridging really quickly, like an asynchronous operation that ends within a second might just be better than a synchronous one that also ends within a second, but like has to block transfers from occurring that full second. And so you have to pay the full fee for doing that. But I think we'll just see that when like actually these things go live, and then we can properly benchmark them against each other.
Yeah, a lot of fun things to watch for and think about and write Twitter threads about for sure.
Yeah, good way to farm yaps.
Yeah. 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 Cool. Thank you, Karel. That's super interesting. Greg, Diego, do you guys have any closing thoughts? I don't want to have this take up the whole day. I'm enjoying this. I could talk to you guys all day, I think, but I'm sure you all have a lot to do. So I figured this might be a good time to start wrapping things up. Yeah. Thoughts on the future of Interop, things you're excited for, things you'd like our audience to know about?
Yeah, so if I can just relentlessly shield Union, which I love to do. So we just launched testnet 9 like an hour ago. Use it, break it. It contains like an incredible amount of new features, to be honest, from like different pricing APIs that we're using. It's like 20 different technologies that will all apply here. So expect it to break. That's why we get this out here right now for users to test. We'll have some stuff going live in our dashboard for users too, associating with testnet 9 in probably a day or two. So if you're listening, hop in, play around with it. And with this, testnet 9 is the final testnet. Like we keep that running, but the same code is going to mainnet. So now comes a period of bug fixes, which, to be honest, I expect are mostly related on the UI side. Once again, like Interop is hard, and actually like displaying correct values to your user, interacting with public RPCs is difficult to do across many networks. But with that, like Union is close to mainnet as well.
Exciting. Yeah. Congrats. I'll make sure to get a link from you for that. I'm going to put this on YouTube later and have links to everything that we discussed. So got to remember to do that.
Thanks.
Diego, Greg.
No, I think we touched like lots of topics. Of course, I don't know, in the case of based rollups, it remains to be seen whether it will be better than other options. But I don't know, I am excited about some of the things they shared about the Ethereum roadmap, particularly the Beam chain. I think it's like getting CK right in the core. And I think that some things will become easier and easier as we get faster provers. I think that right now we see that CKVMs are becoming like quite commonplace. You have at least, I don't know, 7, 8 VMs with different like strategies, everything. So it's becoming like easier to prove things, and also you have like prover networks. So you are certainly going to have lower proving costs. Okay. So it's exciting on that side, and the good thing is we have an infrastructure that allows us to process lots of proofs in Ethereum, which is aligned. So as we get more proofs, I can assure you you'll get like lower costs. So the more use it gets, the cheaper and faster it would be. So I don't know. I'm excited about these things, and I don't know. Maybe at some point we'll write something commenting on all these topics. You know, I like writing blog posts. It's the way I kind of materialize my thoughts.
Absolutely. And I always love reading them, Diego. Thank you. Greg, let you close us off.
Yeah. I like to say this pretty often. It's like, it's nice to get ambitious at the like base layer, at the protocol layer, to speed things up. You know, but as someone that like spent a lot of cycles in core devs, I also want to make things realistic and say that it's okay if we don't get like single slot finality right away. You know, it's okay if it's 2 slots. And my main justification for it is like, no matter what we're doing, we're trying to optimize to the end user, which is obvious, but the base protocol doesn't have to solve all the problems. That's why, you know, and I think Diego, you brought it up or something, but like solvers are here. That's what solvers are for, and like third parties are for. They're to like help, you know, bridge that gap, make it a little bit more seamless, and maybe pull off like a little bit more advanced functionality than the base protocol could ever do. And so I'm excited for, you know, ZK to finally like actually get us probably closer. But in the interim, it's like, you know, it's totally fine if you have to use a third party, as long as there's like the trust is well structured.
Cool. Thank you for sharing that insight. Yeah, I'm really happy that I was able to get a bunch of like people with very deep experience, like real veterans of the blockchain space, having worked on multiple ecosystems and thought a lot about how to connect different chains. Yeah, Karel, you were mentioning working on Polkadot, and Greg, I'm assuming that you've done your fair share of work in that ecosystem as well, or at least been closely involved with it somehow. So yeah, super cool for me, who really only got into crypto like 3 years ago. So a lot of history, a lot of lore, and a lot of people who are super generous with their time and like to talk about cool stuff. So with that, thank you all again for joining today. Thank you for everyone who listened in. We're going to put this on YouTube. You can find us all on Twitter. And I guess, Karel, you said you're not going to be in Denver, but Diego and I will be there. And Greg, I think I heard you mention Denver as well. So maybe catch you there. And if anyone's listening and wants to say hi to me in Denver, I'll be there. So yeah.
Thanks a lot. See you.
Cool. Have a good day, guys. Bye-bye.